it is very, very difficult to predict the spectrum of atoms that have multiple electrons, an exception can be made if you remove all of those electrons except for one. So if you have an element other than hydrogen and that element is ionized, so that means electrons are taken away, so there's just one electron orbiting the nucleus, then the problem becomes simpler again. And in that case, we can say that we have a situation which is just like hydrogen, and we can use a modified version of Bohr theory to describe that atom. But first, you do have to take away all of the electrons except for one. So the thing that's different is that the nuclear charge for other elements is bigger because they have more protons. So you describe the nuclear charge as Z times E, where E is the fundamental unit of charge, and Z is the number of protons in the nucleus. So for helium, for example, Z is 2. For lithium, Z is 3. For hydrogen, Z would be 1. So in that case, we can modify our equation for the energy levels, replacing the charge of the nucleus with Z times E. And in that case, we get this expression for the energies. So the energies, the energy levels, are equal to, once again, minus 13.6 electron volts over n squared, but then you also need a factor of Z squared, where Z is the number of protons in the nucleus. The wavelengths can also be predicted by modifying the expression we had before, and we end up with 1 over the wavelength being the same expression, but once again with a Z squared term. So if someone tells you that you have an ionized atom so that only one electron is remaining, it's still possible then to predict the energy levels and the wavelengths that are emitted when that one wavelength jumps, or one electron jumps from a higher energy level to a lower energy level. Once again, though, it should be remembered that if you have multiple electrons in your atom, then there's no easy way to predict what the energy levels are. So let's next consider this question. Consider a hydrogen atom and a singly ionized helium atom. That means we took one electron away, and so only one is remaining. Which atom has the lower ground state energy?